All right. Good afternoon. So I'll be doing image classification, and then we'll be looking at two different years of image. At the same time, we'll be seeing how we can project using that same image. So this time around, we'll be looking at a state which is in Calabar, Uyo precisely. So we'll be making use of that data. Now the first thing we are going to do, we are going to make sure our data is prepared already. So first of all, I have my data over here, which is Landsat. Here we have Landsat 8, and over here we have Landsat 5. So for Landsat 5, I'm making use of band 4, 3, and 2. And for Landsat 8, I'm making use of band 5, 4, and 3. So our image for Landsat 4 is 1986, and our image for Landsat 8 is 2015. So we'll be looking at the differences between 1986 to 2015, and then we are going to project. So the first thing we're going to do is to load our Idris. Load our Idris software. Very good. And so here we have our Idris software. Now we are going to be creating a new project. We'll come back to this place here where we have project. I right click and then I select new project. Then I'll be navigating to where I have my data. Then I have PC, this PC, and then I have local disk, and then I have my folder called Uyo, and then here is where I have my working folder. So I'm going to be giving it a name Uyo. So you can see this is where I have the name Uyo, and then the working folder is this. But I will be changing this a little bit, but before then I'm going to be adding a new folder which is known as the resource folder. So the resource folder is actually where I have my data. So I'll be navigating down to that place, and then I scroll down back to Uyo, and then I select data. I click on OK, and then my working folder is a folder which I've actually created called results inside the mother folder, which is Uyo work. So I have another folder called results. Now the next step is to import the bands. The next step is importing the band. So first thing I go to file, I click on import, I click on desktop format, and then I select GeoTIFF. So this is a conversion of GeoTIFF to Idris. So I select this, and then you can see this is the data folder. I click on it, then I try as much as possible to look at the bands I'm importing. So for now, I'll be importing the 1986 data because that's what I'll be working with for now. So 1986, I have band 4, 3, and 2. So I'll be selecting band 2, which is LT05, which is Landsat 5. So here, this is where my result is going to be. All I have to do is change the file name, which is 1986 underscore band 2. So this stands for image year of 1986, and then the band is what? 2. I click on save, and I click on OK. While it's loading, you wait and watch what happens here. So as soon as that's done, that's my image for 1986 band 2. I will be loading for band 3. You click on OK. Here I'll be changing the name to 1986 underscore band 3, and then you click on OK. Next you have band 4. Here, select this, select my working data, make sure it's band 4 of Landsat 5. So here I say 1986 underscore band 4, and then I click on OK. So at the end of this, I have successfully added my bands to the image I'm working with. And so the next thing we're going to do is we're going to be running a composite. But before then, you can click on Files, and then you refresh. Then you can double click on this box where you have the green arrow here. You double click on it to see the bands you have just added. And so I'll be zooming on this to look at the features that I have around here. And here I have some other features here. I'm very close to the water body down here. But before then, we'll be doing what? A composite. So how do we do a composite? You click on image processing, and then you go to enhancement, and then you select composite. So we'll be joining the 3 bands together. So the blue band goes for band 2. So this time around, you are not selecting your work data, you are selecting your results folder. So you click on this, and then you have band 2, and here you have band 3, and here you have band 4. Now the output image, we are going to give it a name as what? 1986 underscore composite. And then you click on OK. Now we have to wait until this finishes. Very good, it has finished. So you can see this is our first color composite of the image that we have. So before we can be able to actually view this properly and then select where we will be looking at or where we would like to work with, we are going to do what we call windowing. So we will be cutting out this image to see where we can work with. So if this is an environment where we would like to work with, or these are the features, or this is the area where we'll be working with, all we need to do is look for where we would like to work with. So we'll be looking at somewhere around this place, and then the next thing we're going to do a process called windowing. So to window this image, we are going to go to reformat, and then we select window. Then from the window, you can see we have our window image dialog box. So here we are going to be selecting our 3 images. So this time around, we are selecting our band 2, we select our band 3, and then we select our band 4. Now we have our upper left column, upper left row, and lower right column. In this junction, we'll be using the row and column positions to window our image. So now when you come to this side, you will notice something downwards on this part here where you have some numbers running. So whenever you come to this place, you will notice there are some numbers showing downwards. So now the first one is what? Upper left column, and then we have upper left row, and then we have lower right column and lower right row. So you will pick a piece of paper and a pen where you'll be jotting down these numbers so that you don't mix them up. So for my upper left column, this is my upper left column, I have a column of 5, 7, 7, 8, and a row of 8, 8, 4. For my lower right column, I have a column of 6, 1, 1, 1, and 1, 1, 7, 8. So these are the values I'll be making use of in my window. So this time around, I'm going to be imputing the numbers I just wrote down, which is 5, 7, 7, 8. For the upper left row, I have 8, 8, 4. and for the lower right column I have 6 1 1 1, and then for the lower right row I have 1 1 7 8. So with this I've been able to select the area where I would like to window. So here I'll be giving it a name as 1986 underscore window. So please always look at the way I'm naming the file so that you'll be able to actually distinguish the files as it is. So as soon as you are done with that, you can just click on OK. And then you might not see any results, but all you need to be sure is that when you refresh on this page, you should be able to see the results of the window. You can see this now. This has been added. And so to really see what we have just done, the window we've just done, you go back to your composites, and then remember you can go to image processing, enhancement, and then you select composite. So it will bring you back to where we are here. So this time around we are selecting the windowed band, which is window band 2, window band 3, and window band 4. Now with this, our output image is going to be 1986 underscore window underscore composite. So we are doing the window composite. So we click on OK so that we'll be able to see the results we will get. As you can see this clearly, this is the image that we have, or this is the resultant image from the window we have just created. So the next thing we are going to be doing now is we are going to do a classification on this, which is the supervised classification. As you can see, there are some features we can be able to identify in this image. We can identify built-up area, we can identify vegetation, which is in red, and we can also identify water body. So for the purpose of this tutorial, we'll be looking at just 3 features, or 4 rather. We can identify vegetation, we can identify built-up areas, we can identify uncultivated lands. So that is what we will be working on right now. So now, for us to do a supervised classification, all we need to do is, first of all, we click on this, digitize, and now to do this, we're going to be giving it a name, and the name will be what? 1986 LULC. And then you leave this as default, and then your ID of value will be 1. And then before you continue, you need to pen down what number you are going to make use of. 1, what feature is going to be your second feature, your third feature, and your fourth feature, as many features as you are looking at. So for me, my first feature is built-up area. So I'm going to write built-up on my piece of paper. My second feature is going to be vegetation. My third feature is going to be the water body, and my fourth feature is going to be the uncultivated land. So these are our features that we will be working with. So I'll be starting with this one. For the first feature, which is built-up area, you click on OK. When you click on OK, you can see the sign has changed, and then you can actually zoom in or zoom out on your feature. Make sure you have the pixels that represent the built-up area, and when you're done with your polygon, you double click, you right click to have a feature down there. Then you can actually spam to areas where you have other features. Then the next thing you will do is you go back and click on digitize. Now you have to be careful here, you have to read this properly, and all you need to do is you click on OK. Now because you are not through with the first feature, which is built-up area, your ID or value has changed to 2, so make sure you change it back to 1 until you are done with what you are doing. So I'm going to do this, I continue doing this, I do this, and then when I'm done with this, I right click. So that is my built up area. So you can be able to choose other points also, and at least have enough points. In this case, I'm changing this to 1, and then I select this, select this, select this, select this, select this, and then let me pick somewhere around this place. I add this, I say 1, I said select this. Okay, good. So I think I've selected some features, major features for built up area. So the next feature, which is 2, is my vegetation. So you can see on this place here I have my vegetation. So I'll be picking my training samples from there. Then this time around, remember vegetation is number 2, so you leave it as number 2, and then you click on OK, and then I click this and do this and do this. You can see this now, that is vegetation. And then here also I have it in red. In first color composites, vegetation is what is red. So right this time around, here it has changed to 3 again. I'm going to be changing this back to 2 until I am satisfied with the number of pixels or the number of training samples I have collected for my feature. So you can see even on this side I have a mixture of red here as vegetation. Here I select 2. So this is what you are going to do continuously until you are done with all the features. Now for water body, you can see this is water body. All you need to do, remember water body is number 3. You select 3 and click on OK, and then you go around and select the pixels that you can see. All these areas are places where you have water. So you select it carefully, and then you remember to always change this to the feature number that you are working with, which is for now, which is water body. And so you do this for all features that are water body or carry the same color indices. So this is 3, and then that is water body. So as soon as you are through with that, we'll go to the last one, which is uncultivated land. And so for all cultivated land, that is 4. You click on OK. So you see areas like this, uncultivated lands. So you have them around here. You select this, click on 4, click on OK. So I have uncultivated lands this way. So as soon as you are through with this, we are through with, let's say, the major picking of the training site. What do? We save. You can see this is our digitizing. We need to save our data. So you click on this, and then it will ask you save changes to vector. You will say yes. Now as soon as you've done that, the next thing we are going to do is what? We are going to see how we can now run continue with what? With the maximum likelihood classification. Now we are going to come to image processing, and then we'll go to what? Signature development. Please take a good look at this. You go to signature development, and then we are going to create a signature which is known as what? Make sig. So we select this, and then here it's asking enter the signature file names. Remember, we have saved what we just digitized just now. So you click on this, and then you select 1986 LULC, as you can see, and then you click on OK. Then here it will request us to enter the names of the features we have just generated. So for the first one is what is built up. The second one is vegetation. The third one is water body. And and the last one is uncultivated land. And so now we have been able to impute our signature name, which is also known as the features for each polygon. So we click on OK here. Now here it's asking us bands to be processed. What bands are we processing? At this point in time, we are working on what? On our windowed composite. So you change this to 3, and then you select our window composite, which is 1986, window band 2, then we have window band 3, and then we have window band 4. So all we need to do is what? We'll click on OK. Then you wait, you watch this until it's done. As soon as it's done, then we'll have our results. So the next thing we're going to do right now is what? We're going to do our maximum likelihood classification. So you go back to image processing, and then we'll go to hard classifiers, and then you select max like. So from here you can see it has brought out the table. All we need to do is we are going to insert our signature group. So you can see it's showing us value, probability definition. So we don't need to tamper with that. All we need to do is insert the signature group we just created, and you can see it here. So you click on OK. You can see automatically it has brought in the names of the features that we are trying to work with. So here we're going to give it a name as what? 1986 max like. Please, you have to keep to this naming, or so that when you want to work with the next image, you won't be having issues with names. So all we need to do right here is what? We click on OK, and then when we click on OK, we wait for it to run. You can see it's trying to work, and then we'll wait until we have results. So very good. So you can see this is the final result of our what? Of our maximum likelihood classification for 1986. So with this, you can be able to see that this is how this particular place looks like. And then if you want to look for more information, you can right click on this. You can look at the map properties. You can update the legend. But what is more important is what? The area. You can actually calculate the area in cells, hectares, acres, square meters, square feet, and square kilometers. In our own jurisdiction here, most times we use square kilometers. So let's look at the areas that are being covered by these features in square kilometers. So all you need to do is click on this, and then you'll be able to have your results. You can see now, as far as this is concerned, we have about 9.179 square kilometers covered by built-up. Then we have 36.81 covered by vegetation, 17.59 by water body, and 25.09 by uncultivated land. So what this is trying to let us understand is that we have the availability of more vegetation than what? Than the built-up area. That is, the vegetation covers a higher percentage than the built-up area in 1986. So we are going to be looking at the changes, what has happened between 1986 and the next year that we'll be working with, which is 2015. So looking at 2015, we will be looking at the same thing here, the same study area, and then we'll be seeing what has changed over what. So you can decide to keep this result. All you need to do is save to file, or you copy to your clipboard, or you can copy it and paste it in your Word document or in your Excel sheets. But for me, I'll be doing this on my Excel sheet, so I will copy this, and I can decide to say copy to clipboard, and then this is my Excel, and then I load my Excel, and then here, and then I can paste. So you can see this now. So this is my results here now. So both in square kilometer for 1986. So I'm going to be putting this here. 1986. So I'll be able to know the difference. Now I'll be minimizing this and coming back to this. So I'll be repeating the same step here by working on what my 2015 image. So the first thing I'm going to do again, I will close this. All I need to do is close all these. I'm done with this for now. I'll be coming back to it, and then I close this, I close this, I close this, and I close this. Now you can see I have a free workspace right now, and this time around I'll be working on 2015 image. We want to see the changes between 1986 and 2015, and after seeing the changes we'll be going further to see how we can project to know what's going to happen in the next coming years. So first thing we're going to do now is we're to import our image of 2015. So remember desktop publishing and then GeoTIFF. From here, this time around I'm selecting my data, and then remember I'm working with what? With Landsat 8. So please don't get confused. Landsat 3 for first color composite, Landsat 5 for first color composite is 432, while Landsat 8 first color composite bands are what? 543. So please don't get it wrong. So now here I'm going to be putting this as what? 2015 underscore band 3. So this is my 2015 image, band 3. Then I'll be loading that quickly while it runs. Then the next image I'll be loading will be my image for band 4. So the next one is what? 2015 band 4. Click on OK, and then here I'll be changing this to 2015 underscore band 4, and then here I'll be clicking on OK. Then we'll wait until we have our result. Okay, good. So here this is our result for 2015 band 4. Then we'll repeat the same step for 2015 band 5. Now we'll click on OK. Here I close this, and then I change the file name to what? 2015 underscore band 5. Here I click on OK, and then I wait for it until it finishes. Okay, good. Now I have band 5, I have band 4, and I have band 3. The next thing we're going to do is we're going to repeat the same step, which is what? We're going to run a composite. So here I'll be running a composite, which is here image processing composite. So this time around we are using our what? Our result folder. So we'll click on this, and then we have our data here, which is 2015 band 3, 2015 band 4, and 2015 band 5. Here we're going to give it a name as 2015 underscore band 2015 underscore composites. So we'll click on OK, and then while it works we'll wait for the result. Okay, very good. Now you can see this is our result for 2015. So we'll be looking at this, and then we'll be seeing what has changed from what to what. So in this point in time I want you to look closely, because we'll be using a different method to do to window our image. So the next thing here is what is windowing. This time around we are working on 2015. So I come here, I select 2015 band 3, 2015 band 4, and 2015 band 5. Now we don't need to write down the rows and columns anymore, because we are trying to use the same study area. And now that we are using a different image, we want to make sure that all the images have the same area extent. So we are going to be making use of the third option, which is an existing windowed image. So our existing windowed image is the one we used previously, which is in band 1986. So I'm going to be selecting this, and then I'll be selecting my 1986 window composite. I want you to look at this very well. We are making use of our 1986 window composite to window our image. Then as you can see, automatically it has added the coordinate system for us, the coordinate points for that particular image that will be able to cover our image. So here what we need to do is just write 2015 underscore window. So this is going to be our window for our 2015 image. So let's see what it's going to give us. You can see it has finished running. So the next thing we're going to do, we're going to check out for the composite. So over here you can see it's just like nothing has happened, but something is there. So all we need to do is right click and then you refresh. Now you can see it has added some data here, which is what 2015 Windows 2015 underscore Windows 2015. So that's what we'll be working with right now as our composite. So here we'll come here and then we'll select our 2015 window 2015 underscore band 3. So that's our data that we are going to be making use of. So I'm going to be adding this. Then here I'm going to be having 2015 underscore window underscore composite. Then you click on OK. Once you click on OK, you wait for it to run. Very good. Now, mere looking at this image, you will find out that so many things have changed. Now, I'll be bringing in the composites for 1986. This is the 1986 window composite. Here is it. Now, you can see that I am having the same image. You can see this now. So this is for 1986 and this is for 2015. Are you seeing this now? So if you look at this properly, you'll find out that built-up area has increased drastically. If I reduce this to the same size, or let me just put it this way, can you see this? So this is 2015. You can see that there's a lot of development in 2015 than in 1986. But we can just see how much development it is, or how many, what is the square area of development until we process the image. And you can see the whole of this place you are seeing here are what are built up areas, while here we only have the built up areas around this place. So you can see there is a huge expansion in this particular part of the city of Uyo. So now the next thing we are going to be doing is we are going to be processing this image. We want to see based on the same classification method, and then based on the same features we'll be looking at. So we'll be looking at the same features, which is built up, vegetation, water body, and uncultivated land. So far so good. I'm trying to find out where I can see water body, but you see some areas have been washed out, or probably have been closed up, or maybe has been sand filled, something. But I think I can be able to see some particles here. This is a kind of a water body here, although very, very small. But we'll be working with that, and then we'll see the results we'll be getting. So I'll be closing this, this is 1986, and then I'll be working with this, which is 2015. So you can see this is our image for 2015. Now we are going to be doing the same process of digitizing our image. So remember, our first item is what built up area. So I'll be clicking on this. This time around here I'll be typing 2015 LULC. Now LULC stands for land use, land cover. Now remember, our ID is 1, and 1 stands for what? Built up area. So all these areas are my built up areas. So I'm going to be taking them gradually And then here, remember I'm changing this to 1 because I'm still working with what? Built up areas. So let's see. And then as soon as you are done clicking around, you do what? You right click. Now select this, click on this, and then I have 1 because I'm still working on what? Built up areas. Now I reach here, I right click so as to have my polygons. I think that's okay. Now the next one is what? Vegetation. I come down this way, I have vegetation here, and then I select this. Remember vegetation is 2. I click on OK, and then I try as much as possible to go around where I have vegetation. So you can see, including this, you know, in vegetations we have both light forest and dense forest. So if you want to go further, you can actually differentiate between farmlands and forest. But for the purpose of this tutorial, we're going to just group everything as vegetation. So here, now on this part here, this part is quite thick. I'm going to be picking some samples here also. So here, this is 2. I click on OK, and then I have this here. So I think that will be okay for this, or let me just pick 1 or 2 points up here. These areas looks like farmland. You can see the reflection is quite brighter than the other ones that are darker. So here I pick a point here carefully, and then good. So let me pick one on this part also. So now the advantage is that the more areas you pick, the better your accuracy in your classification. So try as much as possible to probably zoom in very well so that you'll be able to get exact features you are trying to work with. Now the next one we have is water body. Although water bodies are not so much here, but we'll try our best to bring out something. You can see this is something around blue here. So for now, I think this is the only visible feature we can see for water body. So this is 3. Water body is 3, and then we'll be picking this up here lightly. So yeah, that's water body. And then which other place do we have water body? Not that I can see anyone again, and so we'll leave that for now. Now the next thing we'll be looking at is the uncultivated land. I have some areas where they are looking at like uncultivated land somewhere around here, and then here that is 4. Uncultivated land is 4, and then I have some uncultivated land. Let me just group them at once, and then okay, and then I have well, I have some white patches which are bare ground. Also, you can see these are bare ground, so they are also uncultivated lands, or bare ground uncultivated land. And then you select 4, remember here, and then I pick this, and then here I can see this is also an uncultivated land. So here I select 4. Remember, we have just 4 features, but the system is telling me next, which is 5. So make sure you are very careful about that, so that you don't add a feature that you're not supposed to add. So with this, all I need to do is I've been able to complete 4 features. So I click on what? Save. Remember, this is our save digitized data. Click on save, and then I click on yes. This time around, I'll come back to image processing, and then I go to signature development, and then I make sig. This time around, I'll be selecting this, and then you can see I have 1986. Now I'm having what? 2015. So I'll be working with 2015, and then I click on OK. Now I'm going to be entering the signature file. So the first one is built up, followed by vegetation, followed by water body, followed by uncultivated Now I click on OK. Now here I'll be changing this to 3, which is my 3 bands. This time around is going to be 2015 band 3 window band, 2015 window band 4, and 2015 window band 5, and then we click on OK. Then here it's going to be asking you, this is existing already, would you like to overwrite? Please click on yes. You click on yes, you click on yes, click on yes, and then you say yes to all. So because you don't need to have repeated data. So now it has brought out a report for you, which is which has the sample size, the class name, the sample size, and then required minimum size, which is 30. So each of them have more than the same sample sizes. So now we have just one that has not met the requirement. You can see the class ID, which is water body, just have 14 samples, so we have to make sure it's up to 30. You can see that's an error message, so we have to go back, look for where we have water body, and make sure we have at least 30 watts for us to meet the minimum requirement. So now what do? We have to come back here, look for areas where we have water body, and then make sure that we digitize it. So I'm going to be looking critically. Now I can see something around this place here. I think this is a water body around here, and then here, remember, I'm going to click on this, and then we're going to click on add. Remember, it's giving us 5, and then our water body is 3, so you change this to 3, and then we are going to be adding this to it. So we'll be adding this to it, and then we'll be looking for other patches of water body just to make sure that we have more than 30 pixels we'll be working with. So this is 3, which is water body. So click on this, click on this, click on this, and this. Then now remember to always save as soon as you are through with this. So you click on 3, click on 3, and then you follow this up carefully. Now let's try and see if we have at least 30 features for 30 samples for water body. Then we click on save, and then we are going to be resaving this. We click on yes, and then we'll go back to image processing. Now let's develop the make signature, and then I click on this, I select 2015, I click on OK, I say enter signature. I'll be doing this again, which is built up, followed by vegetation, followed by water body, followed by uncultivated land, and then here I'll be clicking on OK. Then I'm going to say it's telling me it already exists, so I'm going to be replacing it. So here I'm going to increase this to 3, and then I'll be selecting my bands, which is 2015 band 3, 2015 band 4, and 2015 band 5. So with this I'll be clicking on OK. So here let's see if we're going to have the same complaint. Then we click on yes to all. Now you can see it's already running it. So luckily for us, it has accepted our water. Now the next thing we're going to be doing is we're going to be running our maximum likelihood classification. So you click on hard classifiers and select maximum likelihood. Now from here we are going to be selecting our insert signature group. This time around we are working with 2015. So you click on OK. You can see it's up. Then here we'll be giving it a name as 2015 max like. So that is our maximum likelihood classification. Then we'll click on OK while we wait for the results. So good for us, this is our maximum likelihood classification for 2015. And then for 1986, this is it here. Now you can actually see the difference, and you can see the difference here now. So this is our 2015 image, maximum likelihood. Let me bring this way a little bit, then you can see this. So this is for 2015. Now if you notice, this is built up and this is our built up. You can see built up has increased. Now you can decide to check this out, and then we click on calculate area square kilometers, and then you can see this. Now you can see for 2015 built up has become what, higher than all the other classes. So from here you'll be able to know that built up has increased over other classes. Now how do we really get to know that? Let's see how to do that. Now we're going to be doing a little bit of modeling. We now have our 1986 data, we now have our 2015 data. Let's see the difference. Let's see what has changed from what to what. Now Idris has a modeling function which we call the under this you have these features. You can actually go look at it carefully. Then we also have the empirical model development, but this time around we are looking at what, the land use change modeler. So now we have the land use change modeler, we have art trends modeler, we have geomod, we have Markov, and we have CA Markov. So we'll be looking at CA Markov and Markov at the same time under what, the land change modeler. So I'll be selecting this to load the land use change modeler. So carefully enough, this is what our land use change modeler. So we want to see the changes, what has changed over what. We don't just want to look at the statistics and say, oh, this has actually changed. We want to really see the change in what we see in our image. So look at this carefully. This place is a little bit trickish, so we are going to be very careful on how we make use of this. So first of all, we are going to be creating a new project here. Now this is land change modeler project parameter. So here you can see it's asking us use existing projects. No, we'll be creating a new one. So this is 1986 2015 LCM. Are you with me now? So that is the name of our new that will be the name of our new land change modeler project details. Now what is our first image? Our first image is what, 1986. So you click here. Now please look at this carefully. You can see there is no date. So let's see what happens as soon as you add your image. Now remember, at this point we are working with what, the maximum likelihood classification we've just done. Now the maximum likelihood classification is the same thing we know as what, as supervised classification. It is not an unsupervised classification, it is what, supervised classification. So you click on this and then you click on OK. Now you can see automatically it has added the date. It's very important, it has added the date. Are you seeing that now? Now the next one is what, later land cover image. So we click on this, and then our later land image is what, 2015 marks like. Now there's one more thing with this software. You make sure you use the same syntax, because if you are using a different syntax you are going to encounter some errors. So the way you label your work from the beginning, make sure you follow suit. Now you click on OK on this, you can see automatically it has added our 2015 image. Now here you can decide to create your change maps, and then you can try to see your change analysis. You can see with this you can be, now these are what, the gains and the losses. Are you getting me now? So between 1986 to 2015, you can see this, between 1986 and 2015 automatically you can see what is gaining and what is losing. Are you seeing this now? So this one here is what is losing, and this is what gaining. So you can see built up has actually gained in 2015 over what, over 1986. Are you seeing this now? So vegetation has actually what, vegetation was not that much, and you can see water body, almost the same thing. Are you seeing this now? And then you have uncultivated land has actually increased a little bit. You can see. So that means this has reduced drastically. That's to tell you that the rate at which built up increased was actually at a very, very high rate between 1986 and 2015. So if you make your calculation very well, take for instance, you do this, you have your calculator here, and then you say you want to know the difference of these changes between this year and this year. It's so simple. All you need to do is 2015 in the space of 1986. So you have just 29 years. So let's say an average of 29 years, this is what has happened. And then this is what your change analysis. So this is actually what has happened between this. So if you want to go ahead, you want to look at the maps and gains, losses, that's by each factor or by each feature, you are able to use this software to be able to see that. Now if I close this, I come back here, now I have this. Now the next one you see here is what? The spatial trend. This is what? The spatial trend. You want to see it, the trend at which this is changing. That is what has changed from built up. You can see this is map spatial trend from built up to vegetation. You want to see the spatial trend, how it is changing spatially. Then you'll be able to use this tool to be able to see that. Now let's look at what has changed from vegetation to built up. Now I go up and click on this, and then you click on map trend, then you'll be able to see a result. You can see this is the spatial trend in cubic meters. So this is a change from what? From vegetation to what? To built up. So all you need to do is understand what you are trying to work with, and then you'll be able to make use of these tools appropriately. Now the next thing we are going to be looking at is what? Change prediction. We want to see how we can predict. How do we predict into the future? We've looked at these images. Okay, we know in the next 30 years, between 1986 and 2015, which is about 19 years, this is what has happened. Then in the next 30 years, what do you think would have happened? Or let's say in the next 60 years, how is this place going to look like? So that is what we'll be looking at now. So in the next 60 years, that will be what? You'll be adding 2015. Now this is 2015 plus 60. This is what? 2075. So by 2075, we would like to know what is going to look like in this particular city. So how do we do that? Then all you need to do, from your change modeler, you just click on change prediction, and then you'll be able to look at what? Your change demand model, and then you can be able to look at what? Your dynamic road development and other factors. So we'll be coming back to this place, and then all we need to do is come back to modeling. You can close this, you can decide to close this, and then you save your project. You can come to modeling, and then here we'll go to what? Markov. Then from Markov you'll be able to create what? Our transition estimation. So now our first earlier image is what? Our first earlier image is 1986. Don't forget, this time around we are working with what? With the maximum likelihood. So you click on OK, and then our second land cover image is 2015. You click on OK. Then this is what? Our prefix for output conditionality probability of image. Now our prefix has not been created yet, so we need to create our prefix. So how do we do that? We'll come to our modeling, and then we'll go to our CA Markov. Now from our CA Markov, we're going to be creating our what? Our prefix output for conditional. Okay, good. For this, we'll be looking at this. We'll be looking at you will write the name here. So for this thing we're going to be saying is 2075. Sorry, please, I beg your pardon. This will be 2075 underscore, let's just give it a name as Uyo. We want to see how Uyo will look like in the next 60 years. So the number of time periods between the first and the second land cover images, which is what, it's 29 years. And then the number of time periods to project forward from the second image is what, is 60. So we are projecting for the next 60 years, and then your potential error, you leave it at 0, then you click on OK. Now it's going to create a file, which is this. So this is our probability, which actually tells us. So this is still the same thing as what we call the matrix. So this is actually the probability, this is the matrix. Are you with me now? So this is the error matrix in which you use in calculating what your probability of what, of change. Now you might wish to save this. As you know, you select your clipboard and then you can save. Now you come here, our basis land cover image here is what, is 1986, which is this 1986 marks like. Our Markov transition area, which we just created, is this. You can see this 2075. You select that, you click on OK. And then transition suitability map collection, you can see it is what, 2075 again, Uyo. You click on that. Now your output is what, you give it a name as what, 2075 underscore prediction. So we are predicting what it's going to look like for 2075. So this might really take time. All you need to do is fold your arms and wait. So now I have about a pass of 1 to 120. So you wait until it completes its processing. So as you can see, it's almost done. I have 94 out of 120, and so it depends on how fast your system is. If your system is fast enough, and then if your study area is not that large, then it will finish on time. But if it's not fast enough and then your area is large, then you will have to be very, very patient, so that you wait until it runs itself. Okay, so it's almost done. Okay, good. So you can see this is the result of our prediction. Okay, good. So I hope you are able to see this clearly. So remember, our basis land cover is what, 1986. So if you are looking at 1986 to 2075, this is the kind of result you are expected to see. So this time around, we want to be looking at our basics from what, from our earlier image, which is 2015. So let's look at what is going to happen from 2015 to 2075. The previous one was what, 1986, which is our basis land cover image, to what, 2075. So from 2015 to 2075. So you click this. Remember, this is our transition areas. You select it again, and then for transition suitability, you select this, and then here we're going to select this. Just add 1 to it, just for the purpose of differentiating our results. So here we click on OK, and then you can see you are having the same pass. So we'll wait for it, and let's see the result is going to give us. So we'll be using that to differentiate how it is having a projected land cover from 1986 to 2075, and from 2015 to 2075. So let's wait patiently until this is done. Very good. So now you can see this is our prediction for 2075, that's from 2015 to 2075. So you can see this now. If you want to know, you want to calculate the differences, you'll be able to do that from the images. So you can see this now. You can see this is prediction from 1986 to 2075, which is over 60 years, over 90 years. Now this is the prediction from 2015 to 2075. So with this, you can actually export your data to other GIS softwares and then prepare your final map. Thank you. My name is Dombo Tosini.